Vejdirektoratet is a Danish institution under the Ministry of Transport. They have the responsibility of state roads and frequently count and classify vehicles from a number of roads in Denmark. This involves mechanical solution which requires the roads to be closed off for payment cuts and even manual countings. This is very expensive, and Vejdirektoratet has therefore approached Aalborg University to implement a mobile and cheaper solution which can be placed next to the road. To accomplish this, 2 lidars were mounted onto a rack for easy transportation and setup. These lidars should be able to send data to a web server which could display the data in an online interface. However, because of the scope of this project, the web server was excluded, which meant that the data for the interface had to be simulated. The lidar emits infrared beams in a fan-like pattern and measures the time between the emission and reflection on the nearest object. One lidar creates a horizontal plane of beams and is placed at the bottom of the rack to scan the axles of the vehicles. It is to measure the number of axles and the speed of the vehicles. The other lidar creates a vertical plane of beams and is placed right above the horizontal lidar. This lidar creates a profile of vehicles where it can infer a number of parameters. These parameters are used to classify the scanned vehicles by comparing the dimensions to known dimensions of defined vehicle classes. The interface was designed as a website with 3 pages. The home page was designed to provide an overview of the most recent data and the lidar deployment. The lidar overview page was designed to let the user inspect if the lidar were working as intended by checking incoming data and by reviewing live feed of the scanned vehicles and their depth maps. The lidar setup also has a live feed to ensure that it is set up correctly. The statistic and analysis page was designed to compare the different cities with each other by toggling the cities on and off and viewing the statistics on the 2 charts. The interface was tested by having 10 participants complete 12 tasks and measure the completion time, in order to find out if they could complete them within the given time limit. Apart from the task, the participants were also asked about their experience along with a questionnaire in order to discover usability issues. The participants in general were able to complete the task, with the 3 tasks on the statistics and analysis page failing more than others. The interface received positive feedback from the qualitative question as well as the questionnaires, but there were still usability issues discovered, which means that there is still room for improvements. To test the vehicle detection and classification software, the setup needed to be tested next to the road. Unfortunately, only one of the lidar were available at the time of the test, which meant that the test had to be done with only 1 lidar. The test could still remain the same in design, but split into 2 parts, one with a vertical setup, another with a horizontal setup. The 2 tests were performed at an inner-city road, which meant that the cars ended up as an overwhelming majority of the scanned vehicles. The test showed that the computation done in relation to the vertical lidar was the most important to detect and classify vehicles. The horizontal lidar proved to supply insufficient data to classify properly. However, due to a missing variety in vehicles passing the lidar, not all classes are represented, and thus it would be wrong to conclude that the algorithm is perfect. Nevertheless, the results indicate that the attributes and classification algorithm is headed in the right direction, but correct verification of this requires more variety in vehicles and both lidars to be present. To conclude, the interface was deemed usable, but there was still room for improvements. The vehicle detection and classification software seemed reliable, but another test with both lidars would have to be conducted in order to draw a clear conclusion.